This is Med, Math, and Beyond. Created this video series for paramedic students to cover the basics of doing medical math, dosage calculations, that kind of thing. But this could equally apply to anybody, either students, current providers, anybody who's in a position where you're going to be drawing up, calculating, and administering medications. So I find that a lot of students are intimidated by medical math. It's understandable because a lot of students in general aren't fans of math or don't feel particularly strong in their math skills. And then you add the complexities of medication calculations, and then you add in the consequences of medication errors, and it's understandable that it's kind of a stressful process for some people. So I'm going to try and break it down in some basic terminology, some basic strategies, some formulas, and different ways of thinking about it in order to try to make this a little simpler. So here we go. To start with, you got to know the terminology. And when we're doing drug calculations, there's a few terms that are pretty common and very helpful in keeping the math and the formulas simple. First is desired dose. So desired dose is the total amount of medication you're going to actually administer to your patient. Most of the time, that's going to be in milligrams or micrograms, and sometimes grams. There's other measurements are used for some medications, but most of the time, especially in emergency medications, it's going to be measured in milligrams or micrograms. The next thing we need to think about is the medication on hand. And that term on hand means how much do you have? How much do you have in that vial that you're holding, in that syringe that you've drawn up, in the item that you're holding? That's the medication on hand, the total amount of micrograms, milligrams, or grams that you have. The next term is you need to pay attention to the volume on hand. In other words, how much fluid is there? How much total liquid is there that drug is in? So we have the medication on hand is the amount of micrograms or milligrams in there. The volume is the amount of liquid in there. When you look at both of those together, this is how you get to the concentration. Concentration is the amount of medicine divided by the amount of volume, and it's always calculated down to what is in 1 milliliter. And that's an important point, that everything has to be broken down to how much is in 1 milliliter. If you miss that step, you're going to get drug dose calculations wrong most of the time. So I want to know, is there 1,600 micrograms in here? Is there 3 milligrams in that 1 milliliter, etc.? You need to have that part figured out. So we'll work through some examples as I talk about each of these. And the first example is ketamine. So we'll say the desired dose is 15 milligrams. That would be a typical and appropriate dose for pain management with ketamine. And so if I'm going to know that my desired dose is 15 milligrams, I'm going to grab my vial and look at it, and am I going to identify that I've got 10 milliliters of fluid in this vial? So I know that I have a total volume on hand of 10 milliliters, and I have a total medication on hand of 500 milligrams. So that's important information. The next piece is that concentration that we talked about. And I'm going to know by doing the math that 500 milligrams in 10 milliliters means I have 50 milligrams in each milliliter. And if you don't want to do the math, read the label. Every medication that comes packaged should have a breakdown that tells you exactly how much drug is in each milliliter. Something you have to really watch out for, however, is that the same medication may be packaged in multiple different ways. And this is going to vary depending on where you work, depending on the pharmacy that supplies you, depending on what's available in the national drug supply or what your purchasing person was able to get their hands on. And this might vary from year to year. It might vary from week to week at some agencies. So for example, the ketamine that I just mentioned, you notice the one on the left is the example we just showed. The one in the middle is twice as potent. There's 100 milligrams in each milliliter, and the one on the right is only 10 milligrams per milliliter, so it's a fifth of the potency of the first one. So obviously, you could significantly misdose, either over or underdose a patient if you just got it in your head that you always give a certain number of milliliters of ketamine. If the concentration doubles, you're now giving double the dose you thought you were giving. So you have to pay attention to that concentration carefully. Most medications, as I mentioned, are going to be measured, and dosages are going to be listed in micrograms, milligrams, or grams. One exception that you'll see in emergency medicine is sodium bicarb, which is measured in milliequivalents, and we won't get into the chemical explanation for what that measurement means. But the vast majority of emergency medicines are going to be micrograms, milligrams, or grams. Remember that with metric conversions, it's really, really simple. If I want to convert milligrams to micrograms, I simply add 3 zeros. There's 1,000 micrograms in a milligram. If I want to convert grams to milligrams, each gram is 1,000 milligrams. Same holds true for our fluid. So we know that there are 1,000 milliliters in a 1 liter bag. Again, that 1 liter, you add 3 zeros, that tells you how many milliliters. So those 1,000 multipliers end up in some big numbers when you're doing math, but they're very simple numbers to work with. Key concept here to keep in mind and get clear in your head as you're doing these calculations is that we give milliliters. And what I mean by that is what I'm pushing out of my syringe, what my little syringe is designed to measure, is the number of milliliters of fluid that were there. But what I care about, what my protocol or my medical orders are going to be based on how much drug I'm giving, not how much fluid I'm giving. And so we have to figure out that concentration and do the math to make sure we know when we push 2 milliliters of fluid, for example, that we know how much drug that 2 milliliters of fluid contains. So there's a couple of different ways you can do this. There's different formulas, and I'll give you one basic formula and then a simplified version of it that we use to calculate how many milliliters you need to give. If you take the desired dose, you multiply it by the volume you have on hand, you divide that by the medication on hand, it's going to give you the number of milliliters that you need to administer. Now keep in mind that the unit of measurements must match the unit for medication in hand. In other words, if your desired dose is milligrams and your medication comes in grams, you have to change that grams to milligrams before you plug it in. All of the values, all the units have to be the same for this to work out. So again, we'll use our ketamine as an example. We said our desired dose was 15 milligrams. We have 10 milliliters on hand, so our medication on hand is 500 milligrams total. We can plug those numbers into that equation that I just shared, and it's pretty simple math. I have 15 milligrams, that's my desired dose, times my volume on hand, 10 milliliters. I divide that by the total amount of medication on hand, and I can get rid of the milligrams because they're top and bottom, they cancel each other out. I have 150 over 500. I do that math, and that means I'm giving 0.3 milliliters of this concentration in order to deliver 15 milligrams of ketamine to my patient. When I pull out my 1 cc syringe, I can use a 1 milliliter syringe rather. I'm going to draw it up to 0.3. It's best to just draw up the amount I intend to give rather than draw up the entire vial and then have to waste some. Much less chance of drug dosage errors if you simply drop only the amount you plan to administer at that time to that patient. Another simpler option, I say simpler with a question mark because not everybody finds this simpler, is to do desired dose divided by the concentration. Will also give you the exact same answer, that milliliters to be given. So remember, when we talk about concentration, we're talking about the medication on hand divided by the volume on hand, or the easiest way is to just read it off the label. And since your label is going to tell you the concentration, if you know how much drug you want to give, you know the concentration, you can do the simple math and get that. So back to our ketamine example. We knew our desired dose was 15 milligrams. Right on the label, it tells us our concentration is 50. You divide 15 by 50, and you're right back at that same answer, which is 0.3 milliliters. Again, I mentioned it before, make sure that the units match. The unit of your desired dose and the unit of your concentration have to both be in milligrams or both be in micrograms, that sort of thing. And then this math works, and it works simply. In part 2, we'll talk about dosages per kilogram and how that adds another layer to figuring out appropriate desired dose.